Stripping down science. The Naked Scientists.
Hello, welcome to a very festive Naked Scientists Christmas phone-in. With me, Chris Smith, with Kat Arney.
Hello.
And with Dave Ansell.
Hi there.
This week, we're going to devote the entire programme to answering your science questions. So far, we're looking into whether fizzy drinks can make you drunk more quickly, why, if you have too many of them, those fizzy drinks are going to make the room spin, whether lightning ever does strike twice, and does cracking your knuckles give you arthritis? If you've got any questions for us, grab a pen and paper. We'll be giving you our contact number shortly. Kat.
Thanks, Chris. This week we will be finding out why no pain means no gain. Scientists have finally used a family of firewalkers to discover a gene that enables us to feel pain. I'll be talking about why global warming is making seals get steamy. And scientists have developed a visor to help you see the invisible.
And in Kitchen Science, we'll be battling the breathalyzer, peculiarly in Ely Fire Station, to find out how a breathalyzer works and if you can fool it.
And if you want to have a go at winning a fabulous Christmas present, I'm giving away signed copies of my new book, which is called Naked Science. It's stuffed full of fun and funky science stories like those that you hear here on The Naked Scientists. And to win, all you need to do is decipher some chemical formulae. Now, have a guess at what these chemicals are. They're all connected to Christmas. You might want to write this down. Number 1... C2H5OH, that's number 1. Number 2, C9H8O4, and this one's a long one, C203, H718, O328, N4, K2, Na1, S1, Cl1. I'll go through them again later on in the programme, so don't worry if you've missed them. But the way it works is if you think that C2H5OH, which was the first one I said, is the formula for water, all you have to do is just ring up and say, I think number 1 was water, and number 2 is X, number 3 is Y. We'll give you the prize if you get the most correct answers, or you're the person with the most imaginative answers. So if you make us laugh because it is Christmas, we're going to give you a prize.
The Naked Scientists Podcast, powered by UK Fast, the UK's best hosting provider, on the web at ukfast.net.
Well, there's tales of gloom and doom everywhere. We hear about the dangers of climate change. Depending on who you believe in, we're either going to drown, boil or freeze alive in the next few centuries. But researchers at Durham University and the University of St Andrews have suggested that at least for grey seals, who live on the remote Scottish island of Rona, global warming has actually brought some unexpected benefits. The seals live in colonies, and there's lots of females and their pups who live with a few dominant males, sort of a harem setup. Now, there's been warmer and drier autumns lately on the island, and it's caused pools of rainwater to dry up. These pools are used by female seals for drinking water and for splashing around in. So the female seals have to go further away from home to find fresh water, and this takes them out of the eagle eye of the dominant males they live with. And this means that weaker males actually, can nip in and get their end away.
Do we know that's actually happening, though? Or is that just a theory?
They know it's happening because they've been looking at the genetic diversity in the population, and they found that actually the genetic diversity has increased, suggesting there's more different breeding going on with these weaker males. So it's actually very good because it's strengthening the species, helping to mix up the genes a bit. So at least if you're a grey seal, global warming's not all bad.
It's amazing the lengths that animals will go to in order to get a go at the mating game, isn't it? Because there was a wonderful story that came out from Australia about a year or so ago, and scientists there were looking at the giant Australian cuttlefish. And if you don't know what a cuttlefish is, it's the bone that you shove in your budgerigar cage for the budgie to peck on. But in life, they're really beautiful animals. They've got tentacles a bit like a squid, and then they have this big long body, which is where that bone is, with a frilly bit round the outside. And rather like a chameleon, they can change colour, so they adopt different colour schemes. Now, there are big males and smaller females, but obviously there are some little males as well. And what happens with these cuttlefish is that the big males jealously guard this harem of small females. They won't let the little males get a look in. So what scientists have noticed is that these little males have got a bit sneaky. And what they do is they change their colour scheme to look a bit more female, and they rearrange their tentacles in a more feminine fashion. They sneak past the large male because it thinks it's just another female. They quickly mate with the other female cuttlefish that's sitting nearby, and then they disappear. And no one knew whether this was actually fathering any children on the part of these cross-dressing cuttlefish, if you like. And so the scientists from Australia went down there and they genetically fingerprinted all the cross-dressing males, all the normal males, all the females, and the offspring. And what they found was that 75% of the new cuttlefish being born were actually fathered by these cross-dressing, gender-bending male cuttlefish. So it just goes to show in the mating and dating game, a little bit of subterfuge does go a long way.
So maybe this year, if you're going to a Christmas party and you're a bit of a spindly man, go in drag, and who knows,
Have you tried this then?
Well, I don't need to. I'm a lady.
Yeah.
I am a lady.
Dave? You've got the ponytail. That's a start,
Dave is
isn't it?
not spindly.
I have to say I have dressed up in drag occasionally, but it hasn't been especially successful. But I'm not very spindly, so...
Now, how do we combat global warming? Well, there's a researcher who's based at the Pacific Northwestern National Laboratory in Washington in the US, and his name's Peter McGrail, and he's come up with a very cunning idea, which is that when we produce energy, it inevitably raises carbon dioxide levels in the atmosphere. And carbon dioxide is, we think, linked to global warming and, of course, this seal population problem that Kat's going into, or if you view it as a problem. Now, what he's suggesting, it's quite a novel idea, is that you supersaturate water with carbon dioxide. So you dissolve lots of carbon dioxide in water, and then you pump it down into lava fields, because if you look at North America, there's huge tracts of very thick lava aprons. So when a volcano spewed out lava, it formed this very big apron of basalt, which is what lava is. And if you crack open a bit of lava, you'll see that it's like a sponge inside. It's very porous. So by pumping this CO2-saturated water down into the lava, what they've found is that the CO2, because it's a weak acid, reacts with small amounts of other chemicals that are present in the lava, and it forms calcium carbonate, which is the same stuff, that solid material you see caked around the element in your kettle. So in other words, it turns into a solid. And what they think is that if you pump enough of this stuff down there, it'll form into a solid. There's no chance of it leaking out again. So this is a really elegant way of achieving carbon sequestration.
Wonderful. Now, scientists have developed a thing like a Star Trek visor. You may have seen Geordi LaForge on Star Trek Next Generation with his strange visor, which you could see in all sorts of frequencies, which you couldn't see normally.
I thought that I think he was a great character, actually.
Am I the only non-Trekkie?
Well, this is the Next Generation. He took over from Scotty as being the bloke that would say, "She can't take any more, Captain." And he never used to say that, did he? That became a bit cliche, didn't it?
Somewhat, yeah.
He was blind. And
We're talking about real science here, Chris, not Star Trek.
Anyway. He was blind and he had this funky visor that enabled him to see very, very weird and wonderful spectrums.
Yeah, because we can only normally see three colours. We've got three different cone cells in the back of our eye, red, green and blue. And although light's made up an infinite number of colours, we kind of just say how blue is it, how yellow is it, how green is it, how blue is it. So if you see some yellow light, it could either be pure actual yellow light, or it could be a mixture of red light and green light. Now, Andrew Harvey and some of his colleagues in Heriot-Watt University have built a little machine to help you. So what they've done, instead of just being able to see three different colours, they've got 32 different colours. It actually goes off into the ultraviolet and into the infrared, so you can see loads more things.
So would you wear this?
At the moment, there's some people, some defence firms are developing into like a video camera so you can wander around looking at it. And we're using this sensor, you can do things like see how oxygenated blood is. So if you look in the back of someone's eye, you can see how much of the eye has got nice oxygenated blood.
So what, because oxygenated blood is a different colour to non-oxygenated blood?
Yeah, if you look at it just with normal light, it's quite hard to tell. But if you can tell exactly what the colour is much more closely than your eye can, you can detect the difference. And you can tell where the damaged regions are, which is good for some things. And it also means you can see through foliage and see man-made things in foliage. So if you're a soldier...
How?
Well, if you pick colours of light, which will go through foliage quite well, but will reflect off like mines or booby traps well.
So
it's a sort of camouflage buster then, isn't it?
That's the idea, because camouflage is normally designed to work with our eyes, because why would it have to work with anything else?
So if you bolted that on the bottom of an aeroplane, then an aeroplane flying over dense jungle could see this standing out like a sore thumb.
You should be able to see tanks and things camouflaged far, far better. So it should be very useful.
Well, we've got another story here about the Stardust mission. Listeners with good memories may remember that the Stardust mission came safely back to Earth in January 2006, and it brought with it precious samples of stardust from the comet Wild 2. Now, basically, like the lump of ice and frozen peas that you find at the back of your freezer, comets are sort of dirty snowballs. They contain matter from the very beginning of our solar system. This is 4.5 billion years ago. And researchers at Imperial College London and the Natural History Museum have used a technique called spectroscopy to look at the mineral content of dust samples that came from the comet. And they found that the comet dust is made up of loads and loads of different sort of compositions of minerals rather than just one. Now, what does this actually mean? Well, the scientists think that this means there was loads of mixing going on in our early solar system before the planets formed. So there's really turbulent conditions, rather like a sort of a cosmic blender going on. So some of the comet dust came from what's now the asteroid belt between Mars and Jupiter. Other particles came from a region much closer to the Sun. And because VIL-2 was made in the far, far reaches of the solar system, it's frozen ice from the far corners of the solar system, they think that this means that the dust in it must have come from all over the place, so that when the solar system was being born, all this stuff was all mixing around, rather than the rather more sedate model that scientists previously had. I mean, there's going to be a lot more analysis on the dust samples from VIL-2, but hopefully we'll just discover a lot more about how our solar system was made in the first place.
Yeah, because those comets were lurking out there in the outer reaches of the solar system. They're literally a perfect time capsule, aren't they? Because they've been so cold and so pristine in their preservation, because they're such a long way from the sun normally, that they haven't been damaged.
Exactly, they really are the frozen peas from the back of our cosmic universe.
Well, no pain, no gain, and a bit of research which has originated from Cambridge this week. It's a guy called Jeff Woods who works at the Cambridge Institute for Medical Research here in Cambridge, and they've discovered a gene which probably enables the majority of people to sense pain. But the people that showed them the way to find pain were actually people who were fated firewalkers, self-impalers and roof jumpers, because they went to Pakistan and they'd heard about some families who couldn't feel any pain whatsoever. And in these families, these people could literally walk on hot coals, and they could do it with impunity. Not because they weren't immune to being burned, but because they just couldn't feel that they were being injured.
Was it just the women in the families? Because we all know women have got a higher pain threshold than men.
Actually, no, these were men. And I don't think that's relevant, because actually it's not linked to one of the chromosomes that makes you a man or a woman. It's actually linked to one of your other chromosomes where they found this gene. But what the gene is, it's on chromosome 2. It encodes what's called a sodium channel. It's a kind of pore which sits on the surface of pain fibres, and when the pain fibre gets stimulated by something painful, it allows sodium to go inside the cell and switch it on. So it revs up the cell and makes nerve impulses that you can interpret as pain. But it only seems to be present on these pain fibres, which means the rest of your nervous system and in these individuals, they're completely neurologically normal. So in other words, they can be tickled like anybody else. They have normal cognitive function. They're not in any way impaired in their thinking. And they can feel rough and smooth surfaces, and they can enjoy curry, but they just don't feel that it's burning them. They enjoy the flavour, but they don't feel that it's burning them. And that's relevant because we're going to be talking about why poppadoms curl up in a minute. But now why this is so important is that because we now have this particular receptor which is present on the surface of these nerve fibres, it means that you should be able to make some kind of molecule that can selectively block that channel. And because it's only on pain fibres, you could have the world's best painkiller. And so there's a pain specialist who works at University College London who's called John Wood, and he says this isn't as important as the identification of the morphine receptor, because if you can block it, you should have something which is highly selective for pain, doesn't have any other side effects of other painkillers.
I wish they'd hurry up and find it before I next have to have my bikini line done. Tell you.
I guess that family must have been really badly injured all the time, because pain's very important, because you're always trying to, if you don't know you're being injured, you can end up chopping your hand off and not notice.
Well, that's exactly right. And unfortunately, one of those people who they were studying unfortunately died before the study was over because he jumped off a roof. And the purpose of pain is to teach you, don't do something, it's very bad for you. And if you never have any pain from doing bad things, then you never learn. And as a result, these people do quite dangerous, self-deleterious things. They often had injuries to their lips and tongue because they were often biting their tongue.
Okay, now some scientists in Tennessee have been looking at bat sonar. Now bats fly around and find out where they are using a system called echolocation. This works by sending out a ping of some sound and listening for the echoes coming back, so they can find nice juicy moths and other tasty morsels. Now scientists have been puzzled the way that hundreds and hundreds of bats can fly around all in one place and not interfere with each other, because you'd have thought if everyone was shouting at once, it would all drown out each other and they wouldn't be able to know where they're going. Now, Erin Gillum in the University of Tennessee sat outside a bat cave somewhere near it where bats hunted one by one. They were trying to confuse these bats. They were playing back other bats' calls at the same frequencies as the bats which are hunting were using. And they discovered that every time they did this, the bat signals went up. They put it within 3 kilohertz. The bat signal would just turn up the pitch of their thing. They'd shout at a higher pitch so as it wouldn't interfere anymore. But for some reason they never seem to go down, which is slightly worrying because you'd have thought they'd get as high as they could sing and it wouldn't work. I don't know how closely they test it.
The same thing's happened in towns and cities, though, where birds are singing at different frequencies to avoid being drowned out by the traffic, and whales have now adjusted the tone of their song and the volume of their song to avoid competing with ship propellers.
That's neat, yeah. And these guys are hoping that they'll be able to use the systems that the bats use to stop getting all this interference, so planes can fly around and not confuse each other's radars so much.
The Naked Scientists, supported by the Wellcome Trust.
Time now to head stateside across the Atlantic and to join Bob and Chelsea for this week's Science Update.
This week for the Naked Scientists, we have to apologize for the noise because we're broadcasting from Santa's workshop at the North Pole.
Ho, ho, ho! Get working!
It turns out that all some people wanted for Christmas this year is the answer to their pressing science questions, so Santa asked us for help. Let's reach into this red velvet bag here and see what we can do. Chelsea, will you do the honor?
Sure. Oh, this one's an audio question.
My name is Matthew Vonderov. I live in Bainbridge Island, Washington. Why is it that giraffes don't have a stroke when they bend down to get a drink of water? Because obviously they've got to have really high blood pressure to push their blood all the way up into their brain. And then when they bend over to get a drink, they still have that same blood pressure, but they've got gravity too, so why don't they burst their blood vessel in their brain when that happens?
Excellent question, Matthew. Why don't giraffes have strokes when bending over? Well, we talked to giraffe circulation expert Alan Hargens of the University of California, San Diego. He explained that their brains and spinal cords are surrounded by fluid, just like ours. When they bend over, that fluid rushes to their heads and squeezes the swelling blood vessels from the outside.
So when they bend head down to, say, for example, drink water, the elevation of blood pressure due to the head down tilt could be counteracted 1-for-1 by the increase of cerebral spinal fluid pressure.
Even so, he says giraffes generally don't keep their heads down for long, even when they're sleeping.
That is fascinating. Thank you, Chelsea. Okay, here's another. After hearing about threatened salmon populations, Mary Smith from Mendocino, California, called to ask why we catch and eat salmon before they've spawned, rather than after. We asked University of Alberta salmon expert Martin Krakozik. He says that when salmon reach their spawning streams, they stop eating and metabolize their own flesh for fuel. On top of that, competing for mates and digging nests for eggs takes its toll.
So by the time they're actually spawning and after they spawn, their bodies are really worn out from fighting with each other, from digging, and then they're also usually heavily infected with fungus. They're generally just really gross.
Very ecological, but not very palatable. Thanks, Mary. One last one, Chelsea?
Okay. Listener Lucy Levesque from Augusta, Maine, heard that vaccines are made in fermenters, devices normally associated with beer. She asks, what's the connection? Well, good question. We turn to microbiologist Agnes Day of Howard University College of Medicine.
The principle of using a fermenter is the same for beer as it is for vaccine production.
She tells us that a fermenter is simply a device that grows microorganisms on a large scale. In beer, those microorganisms are the yeast that convert sugars into alcohol. But in vaccine production, they're disabled versions of the disease-causing bacteria or viruses that will ultimately form the basis of the vaccines.
Thanks, Chelsea. Well, we hope you naked scientists stay warm and have a very happy holiday. Until next time, I'm Bob Hirschon.
And I'm Chelsea Wald for AAAS, the Science Society.
Thanks, guys. And there's more from Bob and Chelsea on their website at scienceupdate.com. The Christmas party season is in full swing and most of us are partial to the odd drink, but hopefully none of you are going to be stupid enough to drink and drive. But if you are, and you get caught by the police, you're going to be breathalyzed. But how does a breathalyzer work? Well, never want to turn down alcohol. Derek Thorne and Ali Webb have gone to Ely to find out. Hi there, guys.
Hello there. This week we've actually come to Ely Fire Station, no less. I'm actually wondering whether this is the first time in my life I've ever been in a fire station. I certainly can't remember another. But anyway, it's dead exciting. And I'm here with a couple of people, and we are going to be looking at the science of alcohol, drinking and breathalyzing, basically. So whether or not you can get around breath tests using all these different methods that are out there. And we have a volunteer here who's going to do that. But firstly, I'd like to get on to the man who's going to be leading us through using a breathalyzer. So could you introduce yourself for us?
Of course I can. My name's Mick McCready. I'm a traffic constable on the Road Policing Unit in Cambridgeshire, and my sole objective is Casualty Reduction Officer.
OK, so making the roads a safer place, basically. OK, great stuff. And also with us is a volunteer. So who are you and what have you been up to?
My name's Ali. I'm a backpacker from Australia. I'm helping out with the Naked Scientist, and today I've just had 4 units of vodka in the last 20 minutes. OK, good stuff. Now, we'll be testing you, obviously, later on. But firstly, let's go back to Mick, because in your hand, Mick, is the instrument that we're talking about, a breathalyzer. So just tell me a bit more about it. Like, how exactly do you use this thing?
It's all electronic. The only thing that the subject has to do is to blow into the end of the tube, and the machine is quite clever. It can work out, 1, that you're blowing long enough, and 2, that you're blowing hard enough, because we're after air from your lungs, not from your mouth. It's alcohol in the mouth that gives us false readings. We want a proper reading of how much alcohol you've consumed, and this device is supposed to do it. OK, so this thing is actually measuring the alcohol that's got into your blood. So the thing is, let's say I just go and, down a few shots of vodka and then immediately go and breathalyse. Like, what will that show? It'll probably show that you're under the drink-drive limit, to be fair, because it takes a while for that alcohol to get into your bloodstream, then it goes into your lungs, in your breath, and it comes out of your mouth into this machine. So it does take time, and everybody's different on how long it takes to make them intoxicated or impaired. OK, and we've basically, had Ali drink about, half an hour ago or something. So do you reckon she might have a bit of a reading now? I think she should do, yes. I think it'd be long enough. She said she feels a bit light in the head, which means that the alcohol's got through to the brain, which is what we don't want when you're driving. OK, well, how about we give her a reading, and then as it's doing it, we can kind of quickly talk about how it works as well. So basically, I'll just quickly describe the unit as well. It's not that big. It's about, the size of a very thick calculator or something, and it's got a tube, a white tube running across the top of it, which is what Ali's going to blow through. So would you care to instruct Ali to do what she's got to do to get the reading? Ali, it's fairly simple. Don't blow too hard, but 1 continuous breath, and the machine will make a noise to show that you're blowing properly.
No. OK, here we go, Ali. Right, off you go. All right, and Ali, how was that for you?
It was a very large breath, and now I feel even more lightheaded.
OK, so you nearly ran out of breath there, but it did go through. So what we're seeing now then, there's basically a counter on there, a digital counter, and it's rising up 25, 27, 28. So what's the number we're seeing there?
Right, this is the machine measuring the amount of alcohol, and the machine's calculating the reading. 35 is the legal drink-drive limit, and as you can see, it's gone to fail.
Yeah, she's now up to 38.
She's got to 38 at the moment, and it'll carry on. But as far as that point of view, I'm afraid if you were driving, you'd be arrested and taken to the police station.
How do you feel, Ellie? You're nicked.
I'm glad I'm not driving today.
Absolutely, OK. I'm sure you wouldn't have done. Just quickly, we've also been doing some research, as the Naked Scientist, just on how this thing works. And it turns out it's actually got a fuel cell in it. So if any of you at home have heard of fuel cells, these are kind of the things that could one day power cars. In the car sense, they're meant to use hydrogen and turn that into an electrical current. Well, this thing basically has a couple of platinum electrodes, and it actually uses the alcohol, which is coming out of Ali's blood. It goes back into her lungs and then blows through the tube and into the machine. And depending on how much alcohol is there, the electrodes are able to use that to turn it into an electrical current. And the higher the current means that she's got, more alcohol in her blood, and therefore the reading will be higher. So it's all very clever. Now then, what we want to do now, we're going to go back to the studio, but what we'd like to do is get Ali to try and trick this thing. So what is it you're going to do, Ali?
Well, here we've got some mouthwash, and we've also got some mints and some chewing gum, so I'm going to try each of those, and we'll see what the result is. OK,
fantastic. All right, so we'll be back here at Ely Fire Station, as it happens, with Ali and Mick McCready in a little while, and we'll see what happens to her breath test then. So back to you for now.
Thank you very much to Derek and to Ali. How do you beat the breathalyzer? Well, we'll be finding out in about half an hour's time when that vodka gets really into Ali's system. I thought she spoke quite well for someone who'd actually had 4 shots of vodka in 10 minutes, actually. It's typically a seasoned Australian drinker, clearly.
Obviously.
In a second, we'll be talking to Trevor, who wants to talk to us about various things in Essex, and he's also got some intriguing answers to our quiz. Let me remind you, we're after the solution to these chemical formulae. They're very festive in relation to what they are. If you can decode what these chemicals are. First one, C2H5OH. What's that? If you think, for instance, that's water, you just need to ring up and say it's water. Second one, C9H8O4. What's that? And the third one, this is a complicated one, C203, H718, O328, N4, K2, NA1, S1, CL1. What do you think it is? 08459 25 2000, text 07786 20 1960, or email chris@nakedscientist.com. And I will sweeten the deal for you, because we also have another prize to give away. As well as my book, Naked Science, I'm going to give away a copy of a book called Giant Leaps. It's by John Perry. The Sun newspaper have teamed up with the Science Museum down in London. They've put together this book in which some of the greatest discoveries of all humankind have been illustrated and portrayed in the style of the Sun. So if you look at this one here, it says about Archimedes. It's sort of got this picture of this bloke naked leaping out of his bath, and it says, "You streaker." So it's the sort of Sun headline. And then there's one about the centre of the Earth, and it's core blimey. So fantastic, isn't it? Right, let's have a quick chat to Trevor. Hi, Trevor.
Good afternoon. No, it's not.
Good evening.
Good evening now, yes.
How are you?
I'm fine, very well.
And what would you like to talk to us about?
Well, the thing was, next birthday, I'm 68.
Mm-hmm.
When I was at school, I asked a science teacher a question, and I never ever had a reasonable answer to it.
Okay.
And that is, if you could drill a hole from the North Pole to the South Pole, and it was big enough to drop a stone through, would the stone go all the way through and out the other side and keep going? Or would it just go to the centre and stop? Or would it go halfway through and bounce backwards and forwards and keep going backwards and forwards forever and ever?
It would sort of depend on whether you evacuated, whether you took all the air out of the tube first. Because if there was air resistance, it would drop all the way down. It would be going quite fast at the bottom, but probably not very fast, because it would be losing lots of energy to friction. It would overgo a bit over to the other side. Then it would start falling the other direction. It would start coming north again, and it would sort of oscillate and slowly end up in the centre of the Earth. If you took out all of the air from the tube, it would go all the way. It could drop all the way through the Earth and end up pretty much at the South Pole. It would stop there, and it would come back again, and it would go backwards and forwards. I think it would take about...
simple harmonic motion, isn't it?
It would look like simple harmonic motion, a bit like a pendulum. It would take about, I think, 90 minutes, springs to my mind, is how long it would go back and forth.
I think it's worth bearing in mind, also, if you were to do this, Trevor, Dave's quite right, if you didn't take all of the air out, if you bear in mind that with every... if you think about water as an analogy, every time you go 10 metres underwater, you increase the pressure pushing down on you by 1 atmosphere. Well, if you were to go all the way to the centre of the Earth, pretty soon the air would become so dense, there'd be such a huge amount of atmosphere above you, it would be like trying to swim through a solid, which is why obviously the Earth's core is solid, because of the huge pressure that there is down there. But the thing is that you wouldn't be able to go very, very fast, because there'd be this tremendous resistance. You'd actually fall almost, I think, probably forever, because you go so slowly through this thing, wouldn't you think, Dave?
Probably, I mean, forever is a very long time, but it would take an awful long time to get to the centre of the Earth.
Forever's a very long time. Trevor, do you want a quick go at the quiz? Oh, hang on. You want to have a go at our teaser?
Yep.
I was going to say, do you want to have a go at fact or fiction? But what do you think these chemical formulae are, then?
Well, the last one, I've got a feeling it could be when you look in the garden on Christmas morning, you might find a reindeer poo.
So he's going for reindeer poo. I hope that the people who make this stuff are not going to be too offended when we actually reveal what that chemical is. But that is wrong. What do you think of number 1 and number 2?
I haven't got a clue at the moment.
OK, let me remind you, we're looking for what is C2H5OH, what chemical's that, and also what's C9H8O4. If you think you know the answer, 08459 25 2000. Quick go, fact or fiction for you, Trevor?
Yes, quick one then.
OK, South Africa is the world's leading producers of diamonds. Is that science fact or science fiction?
Science fact.
I'm afraid that South Africa is actually 4th on the list, behind Canada, Russia, and Russia is the number one. And the number one producer is Botswana.
This is Botswana. Next question. Over 300 different languages get spoken in London. Is that science fact or science fiction?
I'd say it's fact.
You're absolutely right. I live there, I should know. London is officially Europe's most culturally diverse city. Over 300 languages spoken there, and members of 14 different faiths and a wide range of restaurants.
Trevor, thank you ever so much.
Okay.
1 out of 2.
Thank you.
Cheers. Got an email here from Joe, who we read this out when we were on the show a couple of weeks ago, Dave, and we didn't know the answer. I'll just remind you of the question, because I've got an interesting answer been sent in to me. Joe says, "Hi, Naked Scientists. I wanted to ask you a question about frying things. When you fry papads, which are poppadoms in the UK, why does it curl upwards away from the layer of oil? We thought about lots of ideas and thought this would be not such a bad thing to ask you. We love your podcast, by the way. We listen to it every week here in India." Well, Tom in West Lothian's just written to me and said, "Chris, poppadoms. I've just been listening to your show from the 3rd of December, and there was a guy on the end of the show asking why do poppadoms curl up when they're fried. He says, looking down at last night's half-eaten curry, which is soon to become this afternoon's breakfast, I reckon the answer is as follows. When the poppadom lands on the boiling hot oil, it's immediately absorbing lots and lots of said hot oil, but only on its underside. This expands the underside of the poppadom, causing it to curl upwards. The solution is to make sure there's plenty of oil in the pan and to hold the poppadom under the oil with a couple of spatulas or one of them big circular mesh thingies, which would be better. Better still, leave it to the pros, nip down to your local kebab shop and get a couple there. And while you're in there, you can even get a curry. Job done. Thanks, Tom.
The other thing which I thought about this is possibly the top of it's exposed to the air, so you get more evaporation off the top. So the bottom's going to fill with oil, the top's going to dry out, and the top's going to get smaller and it's going to curve upwards.
Sounds fair enough to me. We've got a question here from Peter in Great Shelford, and he says, humans spend all our lives one way up, so when we stand on our heads, everything is upside down. Bats spend half their life hanging upside down, so which way does a bat think is the right way up? Now, I've been having a little look into this and been looking at Thomas Nagel's 1974 work, What Is It Like to Be a Bat? Basically, bats don't ever go the right way up. They fly, sort of head down, and they hang, feet up, head down, and basically that's the way they think the world is. There have been some experiments done trying to put bats in low gravity, and basically bats don't really care which way is up. With most mammals, if you put them in...
They do, Kat, when they get unwell. Do you know what illness bats are really terrified of?
What?
Diarrhoea. Sorry, I didn't mean to throw that. You can carry on now, that's right.
Anyway, there have been some experiments done with bats and gravity, where most things, if you put them in wrong gravity, in reduced gravity, they try and they start rolling over and they get very confused. Whereas bats just don't really care. They can fly upside down, they don't really mind. So bats generally hang upside down, rather cleverly, and they don't seem to really mind which way is up. And here's a good bat joke for you. OK, there's a bat hanging upside down in a cave, and he sees another bat standing on the floor, and he says, "Oh, what are you doing down there?" And the other bat says, yoga.
I can beat that. There's 3 vampire bats in a cave, and they're really hungry, and they can't get hold of any blood to save their lives. And then one day one of them says, "I'm so desperate, I'm going out of this cave, I'm going to find us something to eat." So he goes flying out of the cave, and 5 minutes later he's back. He's got his mouth drenched in blood. And the other bats go, "God, where did you get that wonderful blood?" And he says, "Come to the mouth of the cave and I'll show you." And they all go to the mouth of the cave, and he points out and says, "You see that tree over there?" And they say, "Yeah." And he goes, "I didn't."
Laying the facts bare, The Naked Scientists.
In a second, we'll be talking to Colin Humphreys, who's here to tell us why Jesus might have to move his birthday by 5 years or so. But first, here's John in Colchester. Hi, John.
Hello, Chris.
Welcome to The Naked Scientists.
Thank you. My first question is concerned with the insulation against forms of energy, and we can successfully insulate against heat and against light and against sound, but is it possible, do you think, that one day we will be able to insulate against the force of gravity? And is anybody working on it?
The force of gravity is kind of a different kind of thing to heat, light and sound. Heat, light and sound are vibrations of various different types. Sound is a vibration, a physical vibration in the air or in an object. Heat is actually another physical vibration, a very much faster one. And light is a vibration in space itself. So in order to insulate against them, you've just got to kind of get something to damp down those vibrations. Gravity is a force, so it's actually something which pulls something. You can insulate against forces such as electromagnetism because they've got positive and negative. And so if you want to, you can rearrange positives and negatives in order to insulate against it. But with gravity, because you've only got one kind of gravity, you've only got a sort of positive gravity, you can't have the negative ones there, which you'd need to insulate against it. So you can't, unfortunately, insulate against gravity, because it might be very useful if you want to build a spaceship or something. You could reduce gravity under the space rocket, and it'd be a lot cheaper.
It's not being worked on at all. It's just not a possibility.
Not that I know of.
Okay.
No, I mean, I'll just butt in and say, no, I'm sure that's absolutely right. People do talk about anti-gravity, though, and I'm just wondering, if you could really create anti-gravity, maybe you could counteract gravity, so maybe that will be possible in the future.
Oh, right. Okay. Could I ask a question about matter now?
You have to make it a quick one, John.
Okay. I'm right in thinking that matter cannot be destroyed. Is it such that everything that has been created in nature, which creates matter, is still in existence somewhere, somehow, in another form?
That's not quite true that matter can't be destroyed. You may have heard of Einstein's formula equals mc squared, which basically means that mass is equivalent of energy. So you can convert mass into energy or energy into mass, but you can't destroy sort of the total amount of mass and energy together. So the total amount of sort of energy mass stuff that can't get destroyed, and that is always somewhere.
So everything that has ever been created in nature is still in existence somewhere in some form.
Well, all of the energy in the universe is
it originated
still there.
from the Big Bang.
The
Big Bang was a huge pent-up, the unleashing of a huge pent-up amount of energy that existed in a tiny amount of space that was absolutely enormously dense and absolutely minute.
I'm thinking of matter created on Earth like an acorn grows into an oak tree.
Well, those are all atoms, and those are all molecules which are built from atoms, and the point is that all of the things and the complex elements you see here on Earth must have been made in a star somewhere else in the universe, because nothing that was produced in the Big Bang came out more complicated than hydrogen and helium and a little bit of lithium, which are the first three elements of the periodic table. And more complicated things were produced in stars like our own sun and bigger stars that very quickly ram things together and make more complicated elements. And then when the star blows up, it disseminates it around the universe, and they get gathered together to make a new star and new planets and things like our solar system.
Okay, so it does still exist somewhere in some form or other.
The stuff
it does.
The stuff it's made up of.
Yeah. Okay.
Quick go at the quiz for you.
Well, okay, thank you.
Okay.
Go.
People in China drink more tea than anyone else on Earth. Do you think that's science fact or science fiction?
I would say fact.
Next one.
Yes.
What was the answer, actually?
Oh, despite the expression, well, all the tea in China, China's actually not even in the top 5. Thirsty Britons. We are the world's leading tea drinkers, and we quaff down 2 kilos worth of tea bags every year.
Okay.
A soppy inventor has filed a patent for 2-person gloves, John. Do you think that's fact or fiction?
Oh, dear. I'll say fact. Oh.
Yes, obviously for a romantic, the UK Patent Office has received a patent for a pair of 2-person gloves so that lovers can hold hands even in cold weather.
Oh, that's lovely.
John, thank you.
Okay, thank you.
Great having you on the programme.
Thank you.
It is The Naked Scientists with Chris, Kat and Dave. Coming up shortly, Colin Humphreys will be talking to us about why Jesus might have to move his birthday by 5 years or so. He's tracked down what he thinks is the Star of Bethlehem. We'll be finding out why in a second. If you have any questions for us on The Naked Scientists, the phone number 08459 25 2000. Email chris@nakedscientist.com or text in on 07786 20 1960.
Now, many of us here at The Naked Scientists have done our fair share of lab work, and myself, I've handled some pretty nasty chemicals like formaldehyde and benzene, and I've always made sure I'm kitted out with a lab coat, safety specs, rubber gloves, fume cupboard, the works. But did you know that these and a host of other chemicals are actually found in tobacco smoke? Cancer Research UK's latest campaign is called Smoke is Poison, and it's highlighting the fact that although most people know that cigarettes contain tar and nicotine, around 3/4 of people don't realise that there's these really nasty chemicals in there as well, and that's what does you the damage. There's 4,000 chemicals in cigarette smoke, and around 69 of them are known to cause cancer in humans. That's by the International Agency for Research on Cancer. And these include arsenic, chromium, cadmium, as well as things like benzene and formaldehyde. Now, the campaign's funded by the Department of Health, and the charity have teamed up with documentary maker Donald McIntyre to make a series of hard-hitting TV and radio ads. You might have even seen them on the telly. And these show people at work in the lab or in occupations where they use these chemicals and showing the sort of stringent safety measures that they put in place. And then capturing the reactions of these people when they're told that all these chemicals are freely found in cigarettes. I nearly said fags there, but that's very confusing for our American listeners. But anyway, you can find out more about these chemicals and the damage that they do by texting the word poison to 84118 in the UK, or have a look at smokeispoison.com. And if you're thinking of giving up in the new year, well, maybe a bit of formaldehyde and benzene in your last cigarette might give you the incentive.
Fancy listening to The Naked Scientists in your bed, on your way to work, or even at work? Why not subscribe to our podcast? For more information, visit nakedscientist.com/podcast.
It is The Naked Scientists with Chris, Kat and Dave. Got an email here from Lucy who says, is it true that lightning never strikes in the same place twice? What do you guys think of that?
I'd say probably it's not true.
Dave?
Yeah, I think lightning, especially if you have a tall building or something pointy, the top of a mountain, it actually is much more likely to hit somewhere it's struck before, because it tends to hit sharp things.
Yeah, the Empire State Building that's in New York in America got hit 15 times in 15 minutes. A few years ago. So there's evidence that lightning certainly does strike the same place far more than once, 15 times.
Because it's always trying to find the easiest way down to Earth, and if there's an easiest way handy, it'll use it every time.
I never realised this, but aeroplanes can get struck by lightning.
Oh, sure,
A friend of mine I had to fly to Glasgow, and a friend of mine on the next flight got struck by lightning.
It happens with a
crazy.
frequency of about once in every 10 years in an aeroplane's lifetime. And there's a friend of mine who flew to America, and he was already late for his flight. He finally got on the aeroplane. It was delayed landing by an hour and a half because the storm was so bad around Chicago. And then his plane got hit by lightning, and then it got hit by lightning again, so it was twice in about the space of 10 minutes. And then he did land, and because all the flights had been grounded, there were no hotels. And so he then ended up having to spend the night in a 5-star hotel, which is the only thing that had any rooms left over, and it cost him about £500. Then he finally did get his connecting flight to the conference he was going to, and he was so late he missed his talk. So he might as well have not bothered turning up at all. So, I think someone was trying to tell him something there. He got hit by lightning twice. But Lucy goes on to say, what was the best thing before sliced bread?
Obviously, unsliced bread, I should think. We've got a question here from Corinne in the Netherlands. And they want to know, how are seedless grapes grown if there's no seeds? Obviously, plants grow from seeds. How does this work?
Can I just butt in before you start talking about grapes, because you've got me into trouble. Chris Gill from London says, thanks for the show. It keeps me sane on my tube journeys. I have one problem. In a show recently, Chris said that Iceland was a big producer of bananas. I've just bet my colleagues a pint each that this is true, and I've now spent the afternoon trying to prove it in vain. Can Chris let me know where he got this fact, as it doesn't seem to be true? Yes, Chris, I can happily oblige. I got it from Dr. Cat sitting here, and she told me that. Cat, defend yourself.
Well, I'm sure I've read it somewhere.
No, it is sort of true. Iceland is a big producer of bananas in Europe, but it's certainly not a big producer of bananas on the world stage. I mean, the world banana king is actually India. And then there are other countries like Panama, and they produce billions of bananas compared with the tiny numbers that come out of Iceland. But, of course, Iceland has lots of geothermal energy, hot rocks, and that keeps their greenhouses warm.
I stand corrected, rather I sit corrected.
Go on then, seedless grapes.
Anyway, seedless grapes. The correct answer is that seedless grapes, the plants that grow them, are actually clones. So instead of growing them from seeds, they're grown from cuttings, so from existing plants. So obviously the first seedless grapes were a plant that arose through a mutation that means that they don't have grapes. And some growers must have noticed this. And you can basically take cuttings, you take a shoot or a stem off the plant, dip it in rooting powder, put it in the ground, and a new tree will grow. This is how a lot of plants are cultivated now, and also a lot of seedless varieties. That's how they're done.
It's causing problems for bananas, though, isn't it? We're talking about bananas.
Exactly.
Because they're all clones. They're getting struck down by funguses and things.
They're all genetically identical. So if a population is genetically identical, it can very easily be wiped out because it has the same resistance to different pathogens. So that's how it works.
Got a very quick one here. This says, RJ Nilmott says, is it true that if you add fizzy mixers to alcoholic spirits, you get drunk more quickly than if you added the same amount of still water? Well, this is a bit dodgy. Scientists have looked at whether champagne makes you drunk more, tipsy more quickly. There was a piece of research done at the University of Surrey by a researcher called Fran Ridout. About 1999, I think they published this. They took their laboratory. They got all the researchers in their laboratory 1 week to drink some still champagne that had been flattened by leaving it open for a while. Then a couple of weeks later, they got them to drink the same amount of fizzy champagne. And after each drinking session, they got them to do... after each drinking session, they got them to do some simple tests to work out how well their brain was working, and they found that they were working less effectively after the fizzy drink than after the non-fizzy drink. But then, of course, there's a big placebo effect here because you know it's fizzy, and so you're more likely to think that you're getting drunk. Anyway, let's have a very quick chat to Mary, who's in Peterborough. Hi, Mary.
Hello.
Welcome to the Naked Scientist.
Thank you.
What's your question?
I want to know if the muscles in the body can be repaired. Is there any way they can be repaired? Or?
Depends which muscles you're talking about, Mary.
Yeah.
Which muscles do you mean?
Muscles in the lower part of the bowel, you know?
OK, well, those types of muscles are what are called smooth muscle, largely, and this is different to the parts of the body which you move around voluntarily, things like your arms and legs. They have a slightly different form of muscle, but the answer is that they can't necessarily spontaneously repair unless you give them a bit of help. And what scientists are now finding is that there are certain stem cells that we can inject into people, and those stem cells come out of the blood, they go into the muscle, and they then turn into muscle cells, and they can repair. And there was a scientist who's working in Italy who published a paper paper recently when they were looking at muscular dystrophy, which is a disease of muscle in the legs and the arms, skeletal muscle, and they managed to steal some stem cells from the walls of blood vessels, put them into the bloodstream of some dogs that had muscular dystrophy, and the dogs got better, because the muscle cells, the cells they injected went into the muscles and repaired them. But in terms of repairing the bowels, it depends why there are problems with the muscles in the bowels. There are a number of disorders which can affect your intestines, and it depends which one you've got and whether or not it's possible to put it right. There's one disease which is called Hirschsprung's disease, and in this one, for some reason, you don't get proper nerve connections formed along the bowels, and so messages which tell the bowels to push food along don't get through properly, so the bowels don't work very, very well. That's very difficult to repair, unfortunately. But there are some disorders where if there is a bit of the bowel which isn't working properly, by taking it away and stitching the two ends together, you can overcome the problem.
I see. Oh, so it depends really what... it has been caused by severe constipation at one time, yeah.
Well, that's a little bit different, because that argues that probably the bowels underneath are probably normal at one time, and that with the right help they might be able to get going again. Because your bowel has a hell of a lot of nerves in it. It's got as many nerves as parts of the brain, in fact, and it can actually learn. That's why we have a bowel habit. Your bowel actually learns what your daily rhythm or pattern is all about. Anyway, do you want to have a quick go at the quiz?
Yes, please, yeah.
OK, here we go. Vexillology is the study of stressful situations. Vexillology is the study of stressful situations. Is that science fact or science fiction?
I would say that's fact.
Unfortunately, it's false. It's actually the study of flags. It comes from the Latin word vexillum, meaning a flag, standard or troop.
Oh dear.
Next one. To pass the London Knowledge, a taxi driver is required to memorise 25,000 streets. Science fact or science fiction?
Science fiction.
It's actually true, yeah. London cabbies need to know every twist and turn in the capital within a 10-kilometre radius of Charing Cross. Brain researchers have shown that London cabbies have a larger hippocampus than non-cabbies. That's the part of the brain involved in memory and storing information. So fantastic.
Oh.
Thank you very much for your call. Great having you on the show.
Thank you.
Now, it's the second part of our series on the science of colour, and the Naked Scientist's own Anna Lacey has been looking at the dye industry and the science of grey hair.
Last week, we had a look at colour vision and the range of pigments found in the natural world. We humans have used colours from plants, animals and minerals to make dyes for centuries. But in order to achieve the fantastic range of hues we see in today's world, we needed a colour revolution. Here's Graham Alcock of the Society of Dyers and Colourists.
The first man-made dye was produced really by accident in 1856 by a gentleman called William Henry Perkin. There were certain chemicals readily available at that time, and they were using the chemistry of coal tar to try and produce a synthetic cure for malaria, in other words, synthetic quinine. And while he was actually trying to produce a synthetic quinine, he had many, many failures. But what he did do was to produce one day a black sludge in the bottom of a flask, and he was going to clean it out, and to clean it he put some alcohol in, shook it up, and he actually produced this beautiful purple colour. So he did some tests on pieces of silk, and he found out that they were very fast. In other words, they didn't fade in the sun, they didn't wash out, etc. So he set up his own little factory, and along with his brother, who was his business partner, they started to produce this purple dye, which he called morphine.
So can we still see this colour morphine today?
You can't see the original morphine because the original coal tar had masses of impurities in it, and the other chemicals they were using as well had lots and lots of impurities, and you can't recreate the impurities.
The success of morphine, especially after being worn by Queen Victoria, sparked off competition across Europe, with chemists and industrialists vying to create new chemical dyes that not only looked good, but didn't wash out. But what is it that makes a dye stick in the first place?
Each fabric will require a particular dye recipe, and also it will, more often than not, require a mordant. Now, a mordant is a chemical which opens the fibre and allows the dye to actually penetrate really deeply into it, and then it closes up again, which then, if you like, grips it within the fibre and stops it from washing out and from fading in the sun.
However, clothes aren't the only thing to benefit from the dye industry. Hair dye is used by millions of people worldwide, either to hide grey hairs or just for a change. Hair itself is made of a protein called keratin and consists of 3 main layers: the medulla in the centre, the cortex in the middle, and a thin protective cuticle on the outside. But before we look at dyeing hair, where does natural hair colour come from? Here's the London College of Fashion's Judy Beerling.
Hair colour is actually determined by the pigment melanin, which is produced by cells called melanocytes at the base of the hair follicle. And there are 2 types of melanins, eumelanin and pheomelanin, and they have different colours, and it's the combination of those colours that actually gives you your unique hair colour.
Melanin is normally passed from the melanocytes into the hair's cortex. But as we get older, the melanocytes stop working. This exposes the natural white colour of keratin, and the overall mixture of white and coloured hairs gives the hair a grey appearance. But if grey's not really your colour, permanent hair dye can offer a solution.
Permanent dyes work by a mechanism where you mix something that gives you oxygen, in fact it's hydrogen peroxide, with another bottle of stuff containing ammonia and these dye precursors, as they call them. That ammonia has 2 purposes. It helps the hair to swell so those dye precursors can get into the hair, and it activates the peroxide to produce oxygen, which mixes with those dye molecules. The dye precursors are oxidised by the oxygen, and you get slightly larger molecules which get trapped inside the cuticle of the hair. So you get something approaching natural colour in the hair.
So a guaranteed way to have grey-free hair. But there's another surprising beneficiary to this tale. Graham Alcock again.
In a royal procession in 1850, you'd have had to kill over 10 million insects to actually produce the dye to dye the uniforms of the people in the procession. So if nothing else, making man-made dye certainly saved a lot of insects.
Next time, I'll be finding out how Moving dyes led to a headache cure and how a spot of colour can be used to treat disease.
I bet you didn't know that, did you? The Naked Scientist's own Anna Lacey taking a look at the dye industry and the science of grey hair. Now, in answer to our teaser, we've given you these molecules all the way through the programme. We've heard from Rowena in Malden. She says she reckons it's alcohol, tonic and coal. Very good, actually. There's one that's definitely 100% right in there. Norman's in Hunstanton. He reckons alcohol, paracetamol and sugar or icing. He's even hotter, we reckon, because although the second one, the paracetamol's not quite right, that's definitely on the right lines, because what we've got here is we've got merrymaking, we've got good food and drink, and then we've got the morning after. That's a kind of final clue for you. Kat, how are you getting on over there?
We've had an answer from Henry from Wistow, and he says number 1 is ordinary alcohol, ethanol. He has no idea of number 2, and 3 is clearly party punch with everything in it. 1 out of 3, Henry, not bad.
Sorting out the sparks from the quarks. The Naked Scientists.
It is The Naked Scientists with Dr. Chris, Dr. Kat and with Dr. Dave. Now we're joined by Colin Humphreys from Cambridge University. Colin, you think that actually Jesus is going to have to move his birthday by about 5 years?
Yes, I do. I mean, I also think we're going to have to move Christmas to the spring as well. That's another variant on it.
So
yeah.
What's the basis for arguing that?
So the basis for arguing that, the key question is, what is the Star of Bethlehem, which the Gospels say was seen when Jesus was born? And I believe the Star of Bethlehem was a comet, and we can look through Chinese records. They have detailed Chinese records, and the only star which fits the fact between, say, 20 BC and 10 AD, that sort of period when Jesus might have been born, is a comet which appeared in 5 BC. And the Chinese records say it was a spectacular comet with a very long tail, and it lasted for 70 days. It was visible 70 days. And I believe this is the Star of Bethlehem.
Do you know what that comet could have been? Do we have any idea where it could have come from or how long it stuck around? Is it still out there somewhere?
Well, that's a really good question. The answer is we don't know, because we need more observations, because some comets have elliptical orbits, like Halley's Comet, and that means it keeps coming back with a certain periodicity. But other comets are just a parabola, or what's the other one? I forget. So it's just an open orbit. So you just see some comets once, and that's it. You never see them again.
So why do you think that this is a particularly strong contender?
I think this is a particularly strong contender because Matthew's Gospel says the star stood over the place where Jesus was born. And lots of Christmas cards have a sort of star over a house. But what this means is the Magi were travelling from Jerusalem towards Bethlehem, and they saw the star ahead of them standing over Bethlehem. And there's only one star which can seem to stand over a place, and that's a comet. And the comet can appear to stand over a place because it has a long upward-pointing tail which points the head of a comet towards a particular place. And we have in ancient literature 2 other examples of a comet standing over a place. Dio Cassius, a Roman historian, says that a star called Comet stood over Rome. And we can calculate when that was. That was in fact Halley's Comet of 12 BC. And Dio Cassius said this star stood over Rome. And then Josephus, a Jewish historian, said a star shaped like a sword stood over Jerusalem. And in ancient world, comets are often called swords because of their long tails. So we have 2 other descriptions of stars. We know both were comets, and both of them were said to stand over a place. So when the Bible says this star stood over a place, I think it must have been a comet.
Would it have looked the same wherever you were observing it from on the Earth, though? Because presumably if the Chinese could see it, would it look the same from the Holy Land?
Oh, that's a really good question. So whether the place a comet appears to stand over depends on where the observer is, right? So a comet is low in the horizon, and when the Magi were travelling from Jerusalem to Bethlehem, they would have seen it appearing to stand over Bethlehem, but actually it was many, many miles away, low in the horizon. So it depends where the observer is.
What are the other contenders for the Star of Bethlehem, apart from your comet theory?
Well, the most popular theory is a triple conjunction of Saturn and Jupiter. And why that's a popular theory, what's meant by conjunction of Saturn and Jupiter is when 2 planets are in line with the Earth, so they all come together and they look as if they're just one planet, and that's called a conjunction of planets. And in 7 BC, this happened 3 times. So Saturn and Jupiter came together and separated, came together and separated, came together and separated, and that's the main contender for the Star of Bethlehem. And the reason is that if you go back to what the astrologers believed, then Saturn was the father god, Jupiter was his son. So when Saturn and Jupiter came together and separated, people have said, a son's being born to God. And the star background in the sky at which this happened, the constellation of stars was Pisces, and the ancients mapped star backgrounds onto regions of the Earth, and Pisces was mapped onto Israel in Babylonian astrology. So when you have Saturn and Jupiter coming together against the background of Pisces, the astrologers would have said this means a son of God is being born in Israel. And lots of people think that's the Star of Bethlehem. I think that was a precursor. I think that told them something was going to happen, but the comet told them it's happening now. This is going to happen now.
Obviously, you've said that we may never see this comet again. Is there any way to actually prove your theory, or is it going to have to remain that just a conjecture which has some basis for it, along with many others?
There's certain things which suggest that this is really plausible. One is you can say, how do we know the Magi were interested in this triple conjunction of Saturn and Jupiter? Well, we know they were because there's something called the Star Almanac of Sippar. Sippar's a place which is just 30 miles north of Babylon, and this actually records this triple conjunction. It predicts it. They're pretty good astronomers. And so we know the Magi were interested in this triple conjunction. We also know that people are interested in comets, and another astronomer called Ptolemy says a comet in the east means the event's about to happen. So there's lots of things you can put together which suggest this. And the first writer we know who identified what the Star of Bethlehem may have been, writing in the 3rd century AD, a guy called Origen, he says, I believe the Star of Bethlehem was a comet. So there's a lot of pointers that it really was a comet.
Mary and Joseph were supposed to be going to a census to get written up. How does it relate? How does the historical records of when they did censuses relate to your theory?
Okay, well, the question of census is a really good question, and this has puzzled people for a long time. We have records of when the Roman censuses were, and there were none for that time for taxation purposes. But another historian tells us that there was a census, not for taxation purposes, but a census of allegiance. And what happened was the Roman emperor said, I want everyone to sign up for their allegiance, that they obey me as a Roman emperor. And the historian Josephus tells us that 5,000 Jewish people didn't do this, and they were all slaughtered. So this could well have been a census. And from what Josephus writes, this census was in about 5 BC.
There's Colin Humphreys from Cambridge University. Now we have to go back to Ely and find out how Ali's holding up under the load of about 10 shots of vodka. We were beating the breathalyzer earlier. How are you getting on, guys?
Hello there. Welcome back to Ely Fire Station, where I'm still here with Mick McCready of the police, and who's been doing some breathalyzing tests for us, and also Ali, our naked scientist volunteer, who has been drinking And since the first part, when we were here at Ely Fire Station, you've been doing some other stuff, Ali. So what have you been trying to do?
I've just frantically chewed 3 chewing gums at once to try and mask my alcohol breath.
OK, and, I mean, for me, you know, from where I'm standing, I certainly can't smell the alcohol on your breath anymore. I mean, has it made you feel any different, though?
Absolutely not.
All right, OK, fair enough. But anyway, we're going to give that a go. So, Mick, I mean, in your experience, like, do people ever try to trick you when you're doing these breathalyzing tests?
I'm sure they do, but I think it's important to note that we don't have to smell alcohol to request a breath test.
Indeed. OK, so we're going to have a go now then. So, Ali, why don't you do the whole breath test thing again? Here we go. OK, there you go. So we got some big, deep lung air there, and we're having a look.
Well, it's exactly the same as before. In fact, it's going slightly higher, which I would expect, because it does take time for the alcohol to get into the old system.
OK, so there you go. So Ali has failed to trick it, but we have got one more thing we can try here, because we've got some mouthwash as well. So do you want to have a go with that?
No worries.
Yeah, delightful. There you go. She's just spat it into a glass there. Right, so there you go. So she's basically gargled some mouthwash there, and let's have another crack at that, shall we? OK. It still smells lovely from a weir. It smells like a dentist in here, actually. OK, right.
I do like drivers that brush their teeth.
I think you've had a very nice-smelling driver, at least today.
That's gone bananas.
That's gone bananas. That's gone... Oh, my God.
Within seconds, it's shown an error.
It's shown an error.
Completely off the scale.
We've actually managed to, like, scramble this thing. Like, it went up to 100 and 200. Yeah. What happened there, mate?
Well, because it's detected mouth alcohol. I mean, we've just done it straight away. Then she's swilled the mouth out with the alcohol, and the machine's detected that straight away. So
the problem we've had here, of course, is that the mouthwash has alcohol in it. So there you go. You pretty much broke that machine with the level that you actually had there. How do you feel about that?
I'm very proud of myself. I held that mouthwash in my mouth until it stung, so it's worth it.
OK, and so, I mean, if you have someone who's got that reading, then, I mean, what's your reaction to that?
Well, if a driver's prepared to swig all that mouthwash before they get breathalyzed, then they're very silly. I suppose practically we'd give them a bit of time and do it again, but we've also got the option of saying, well, sorry, you failed the breath test, that's what the device says, and you go to the police station and we'll sort it out there.
So there you go. Ali, how are you feeling now?
I feel better, but not sober.
All right, well, thank you very much to you, Ali, and thanks as well to Mick. And I suppose the take-home message here is that no matter how much you try and mask the smell of alcohol, you can't fool the breathalyzer, because that's measuring the alcohol in your blood, which is coming right out of your lungs. So there you go. Anyway, we'll be back again with more Kitchen Science somewhere in the east of England, so catch us again soon. Until then, it's goodbye.
Thank you very much to Derek, to Ali and Mike McCready, who is out there at Ely Fire Station finding out how to beat the breathalyzer, or not, as the case may be. Now, over to our Christmas teaser. We wanted you to try and solve these chemical formulae. C2H5OH, what's that? C9H8O4, what could that be? And then the complicated one, C2O3H718 O328 N4 K2 NA1 S1 CL1. It's not the formula for reindeer poo, as one person has suggested, nor, as Sybil in Sawston has suggested, is it snowflakes or Yule log. The answer's coming up very, very shortly. But first, some other fun festive facts. Kat?
I leave you with the festive fact that the average mince pie contains around 4.8 grams of saturated fat. If Father Christmas ate a mince pie in every household with children in the UK, he would consume over 34,000 kilos of fat.
Which might explain his rotund jocularity. Dave?
Dave actually asked this. What would be the environmental effect of every house in the UK being lighting up its Christmas tree up for 4 weeks before Christmas? I worked this out. It's about the equivalent of 50,000 tonnes of coal, which make about 180,000 tonnes of carbon dioxide, roughly.
So this isn't the garish, gaudy garden display. This is just your Christmas tree.
This is just assuming everyone's put up maybe 1 or 2 strings of Christmas lights in their house.
So if you times that by 10 for someone who's got a really fancy garden display...
Yeah, then they'd probably use sort of about 130 kilowatt hours each.
So that's almost 500,000 tonnes of coal if everyone did that.
Good thing they don't.
Certainly is. Now let's get back to our Christmas chemical conundrum. Dave, first of all, C2H5OH, what's that?
That is ethanol, the alcohol, the stuff that gets you tipsy at
stuff
Christmas.
That gives you the cause to make merry. Right, OK. Well, we had Rowena in Malden who got that right, as did Norman in Hunstanton. They both thought that was alcohol. Next one, Dave. C9H8O4. What's that the chemical formula for?
That is the chemical formula for aspirin, which is great for the morning after.
Certainly. So once you've imbibed a bit too much C2H5OH, you're definitely going to need some of that. Now the complicated one. C203H718 0328 N4 K2 NA1 S1 CL1. Now, no one actually got this right, apart from our guest, Colin Humphreys, who he just saw the formula and suggested immediately that it was the empirical chemical formula, Dave, for
Christmas pudding. In fact, a Sainsbury's tasted this difference, 907-gram Christmas pudding.
and you calculated this how?
I went through all the ingredients, so in fact, all the nutritional information at the back, all the fat, all of the protein, all that sort of stuff, worked out what all of them are made of, added it all up, and it came to that.
I suppose you could extrapolate that to a mince pie, because that's kind of similar. It's a little bit of pastry, so the fat's probably slightly higher, but it's probably not similar, isn't it?
All that sort of thing is going to be roughly the same. It's a fairly approximate thing.
Well, Norman in Hunstanton, his suggestions were alcohol, paracetamol, and sugar or icing. He was probably closer than Rowena, who reckoned alcohol, tonic and coal. So I reckon it has to go to Norman in Hunstanton, because paracetamol's slightly different than aspirin, of course, different molecule, but he was on the right line, so I guess it goes to him. Well, that's it for 2006 for The Naked Scientist. Thank you very much to Dr. Kat and to Dr. Dave. Been fantastic having you here with us for 2006 Naked Scientist. We're back in the new year exploring how to put your arteries right after Christmas. That's right, Roger Corder will be in to talk about the science of wine and why red wine is good for you, and also the dangers or not of coffee and caffeine. In the meantime, thank you very much to our production team, Anna Lacey and Petro Minch, to our kitchen science bunch, including Derek Thorne and this week Ali Webb, who drank about 20 units of vodka, all in the name of science. Have a great Christmas. Keep your emails coming in, chris@nakedscientist.com, and we'll see you in 2007.